Today we are going to discuss about persistent volumes. Persistent volumes are a kind of storage provisioning method in the Kubernetes cluster. As the name says, whenever a mission critical pod requires to store their data outside the pod, we do map the persistent volumes with the respective pods. Again, a persistent volume cannot be directly mapped to a pod. We have to relay another Kubernetes object called persistentvolume_claim. That object we'll discuss in the very next video. So let's move on to the persistent volumes in Kubernetes cluster. There are multiple solutions available for persistent volumes, from our legacy storage system, or our SSD disk, or AWS cloud, Azure cloud, Google cloud, or even NFS server solutions can be used as persistent volumes. The volume will present to the worker node or worker nodes if it is a deployment and there are multiple replicas are span across multiple worker nodes. In that case, we have to present the persistent volumes to the multiple nodes. So once or as soon as we present the persistent volumes, we have to create the persistent volume claims, so that this particular persistent volume claim, that object, can bind with the persistent volume, and this particular persistent volume claim will connect to the, or we will mention this parameter, or we will inject this parameter in the pod creation, that declaration form. Subsequently, whenever we call it using kubectl create command, when we create the pod, this particular persistent volume claim will be mapped. Again, that particular file system will be mapped under, or the particular file system will be mapped with the persistent volume claim. So whenever a user writes the data, first it will write in the persistent volume claim, then it will move on to the data will move on to the persistent volume claim, then it will write to the underlying storage. Let me remind you one thing. There would not be multiple read or write transactions in each object. This would be the way the I/O operations will be happening. There are any persistent volume present or persistent volume claim is present. Nothing is there, right? It's just a clean and neat and cluster. First thing, we have to create a persistent volume. For that, let me create a declaration form. Just keep in mind that using imperative method, we cannot create a persistent volume. We have to use the declarative way, because predominantly we have to mention a lot of parameters. That parameters will never ever support the imperative method. That's the reason we are relying on the declarative method. So as the name says, let me give any name .yaml. Again, the API version will be as v1. The kube API version is v1. And what kind of object are we going to create? We are going to create persistent volume, kind as persistent volume. Metadata. That is again the property of this particular Kubernetes object or the persistent volume. So the name is pv-nginx. I'm gonna create a persistent volume or PV storage. I'm creating that way because it will be somehow good, right? I will label it because I just want to filter it easily for binding. So I will do one thing. Type is type is SSD. I have an SSD. Assume that I have an SSD storage. This particular LUN is coming from an SSD storage. Anyway, in this case, we would be discussing host path. I will let you know that. Again, move on to the next part of spec. Specifications. It's as simple as we are giving persistent volume, right? So that requires a capacity. Capacity, I would have another parameter called storage. Storage we can give, assume that 4 GB. Alright, we have given 4 GB capacity. Next parameter is access modes. It's an array again, so we have multiple modes. So I will give read write once. Back to the slide again. Assume that we have a deployment, and this deployment is having 5 replicas. So the 5 replicas, in the sense, it will be span across the multiple worker nodes. So what will happen is, if we have a /data file system mapped with the persistent volume, in that case one pod will be mapped here and the other pod also should be mapped here. In that case, assume that if we have present this LUN to only worker node 2, this pod which is running on the worker node will lose the data. In that case, we will present the LUN to both worker node 1 and worker node 2, and we will create read write many. That means multiple nodes at a time. This particular persistent volume can perform the read write operations. And the other thing is read only and write many. So one node will have read permission and multiple nodes will have write permission, and the other is read write one. So that means one node will have whatever the particular node we will be mapping it, that particular node only have the read write permission. Remaining nodes will not be having the permission. So we have to set these attributes according to our requirement or the customer demand. So just remember these 3 parameters before we mention the attributes. In our case, we have a 2-node Kubernetes cluster. There is no point of mentioning this read write many. Again, in our AWS or Google Cloud class, we will map this with different advanced settings once we are thorough with the basics. Next is persistent volume reclaim policy. That is, first we will give delete. Okay, I will let you know why I have given this in the next video. This is storage class name. Again, I will give you a brief here. Persistent volume reclaim policy, in the sense, as I told you that we will create a persistent volume, then the persistent volume will be mapped with persistent volume claim. So what will happen is, then this particular volume claim will update to the to any of the pods. In this case, we will have a pod. That pod will write the data to the persistent volume claim, and then it will that data will come into the persistent volume, then it will come to the underlying hardware device. Similar way, assume that we have removed or deleted the pod. We don't want that particular pod anymore, and we have deleted the persistent volume claim as well, since we don't want the pod anymore. In that case, if we select delete option for persistent volume reclamation, automatically the persistent volume will be deleted from the system. Similarly, we have another option called retain. Retain in the sense, if we delete the pod as well as the persistent volume claim, the persistent volume as well as the data pertain to the storage remains as it is, so that either the similar kind of persistent volume and a similar kind of pod is created, so that we can retrieve the data or we can reuse the data, so nothing will happen with the data. And the last one is recycle. In the recycle, it is as simple as just like a scrubbing a file system. Assume that you have a D drive in your personal laptop. Your usage or your project is over, you will just like that wipe the data inside the D drive. That is what is called a recycle. So the data will be just like that wiped out. So this would be ready to allocate to any other persistent volume claim or the pod, whatever it is. Now I will show you that in the next upcoming videos. So we don't want to be a very lengthy and complex scenario. Let's understand the basics and we will move on to that. Alright, storage class. What does mean by storage class? Assume that we have around 4 types of storages in our infrastructure. The first storage is legacy one, that is having that very slow speed hard disks installed, and you have a latest advanced technology storage in your infrastructure that uses the SSD disk, that is fastest. Third is the cloud, AWS EBS block or Azure disk or Google Cloud, Google persistent disk. So you can define, you can categorize these 3 things like a slow, fast, medium, in that way. So what will happen is, for example, you have a database pod would be running on a workernode, and if you plan to allocate the storage to a database pod, in that case you may require fastest storage. That case you can use AWS disk or the latest NetApp SSD, the latest EMC SSD disk storage devices. So how will it come to know? Because we can allocate a bunch of LUNs and we can present a bunch of LUNs to the worker node, and from the worker node we will create a small chunks of storages, that is called persistent volume. So each persistent volume we will label it like in a systematic manner, like a type is SSD, then hard disk type, like that way. Once scenario we will label it fast, slow, that way. So what will happen is, when you create the persistent volume claim, there also you will define the storage class like fast, slow, medium. So it will create a binding criteria, so the appropriate objects will bind together and form a proper channel. We will see that in the next in the upcoming sessions. So here I will mention that slow. Just keep in mind that. Next point is, guys, host path. host path is as simple as in our the first sections in the static provisioning segment we have defined, right? We have to define a storage device. So in this case, since we do not have any other option now, we will plan to preserve the data under /tmp data directory. If you have an AWS LUN, you can very well install the AWS plugin and mention that AWS EBS block device ID, so that the underlying storage will be treated as AWS. Or similar way you can define the Google persistent disk or Azure. As I told, we will discuss that in the advanced sessions. Here again we have to mention path equal to /opt /tmp/data. Remember that we should never ever do this exercise for a production server, because /tmp will may get wiped out at any time, and even the worker node also will get wiped out at any time. So that if the data is pretty much critical, always make sure you would be saving the data, or you would be provisioning the LUNs for creating the persistent volume from an external source, that is AWS cloud or Azure or any other external storage media. Now we have defined the host path. Last point here, we mentioned the API version, kind as persistent volume, metadata as name is PV storage, labels, type we have mentioned here, spec. Here in the persistent volume, remember our predominant concern is capacity and storage, that is 4 GB, and access modes, read write ones, persistent volume reclaim policies, delete, storage class slow, host path, we have mentioned it. Perfectly alright. Now it's the right time to create the same. So it is as simple as kubectl create -f pv.yaml. So we have created a persistent volume called pv-storage. So kubectl get pv. Perfect, we have created, and look at the attributes. Its capacity is 4 GB, access modes read write once, reclaim policies delete, status is available. Remember guys, I'm just stressing this point, status point available. We have some dealings later with this parameter. Storage class is slow. Everything it's good now. So kubectl describe pv-storage. Look at this. Now it is pretty much more information we have received, right? It is saving the data at /tmp data, events none, nothing. So in this case the host path is as simple as wherever the pod would be running, in that particular pod we should have a /tmp/data directory, so that it will preserve the data at that particular mount point. If you have an AWS disk, it would be mapping at that point. Predominantly the labels we will use for selecting while creating the persistent volume claim, that will cover in the next video. So that's it, the data or the video session regarding the persistent volume. Again we have couple more transactions with this that we will cover in the next video, because the next video we will be focusing exclusively for creating persistent volume claim and its features. That video we will be predominantly exploring this reclamation policy and access modes in a detailed manner, so that guys you will somehow get a clear picture about this. And in addition to that, if we will cover the AWS and cloud disk block devices, so that you will be master in the volume management. Thank you so much guys for your time, and have a great day. We will see you in the very next video.